Some series to integral calculus. Some series to integral calculus. The invention what we have done, it is really bringing the fruits. It is really bringing the flower. Mind blowing, amazing. We are taking so many examples so that someone should feel that everything is already solved. There is nothing that need to be invented in this arena. We are in phase to bring all the computation that leads to artificial intelligence or machine learning mathematical computation through a very few algorithms. There are thousands and thousands of algorithms in the thousands and thousands of arena. One, this is what we are talking about is sum series. There can be innumerous sum and series. Can we solve all the sum and series through a single way, and that is through integral calculus. What are the cornerstone? What are the caveats? Where it is different, and those kind of things. Means problem to problem. Where is the reason where we have to tackle differently? So this is what we are talking. We have taken example where we are adding two kind of numbers. One is odd number, one is even number. I mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to n number, where all the even number would become negative. So 2 will become minus 2, 4 would become minus 4, 6 would become minus 6, 8 would become minus 8, and so on. All the odd number will become summation of number. What I mean is, in the slot number 1, I have number 1. In slot number 3, first slot, second slot. In slot number 2, I have minus 2. In slot number 3, I have 3. So 3 will be changed as 1 plus 2 plus 3. Makes sense. Slot number 4, I have minus 4. Slot number 5, it will become 1 plus 2 plus 3 plus 4 plus 5. All the odd slots will become summation of number from 1 to that slot. Means we have brought, means there can be any way, there can be any combination or permutation of the summation series possible. Any, if summation series is leading toward the variable denominator like 1 by 2, 1 by 3, 1 by 4, where denominator is varied, or 1 by 2 whole square, 1 by 3 whole square, 1 by 4 whole square, or 1 by 2, 2 by 3, 3 by 4, like that. If someone sees it, then denominator is also changing. In that manner, we may need to go for the Taylor series or Sir Taylor series and Maclaurin series expansion. Right now we have 1, then 1 by 1, then minus 2, then minus 2 by 1. Denominator are constant. Then we have 1 plus 2 plus 3 by 1. Then we have minus 4 by 1. 1 plus 2 plus 3 plus 4 plus 5 by 1. Minus 6 by 1. All are 1. Denominator, when denominator is not varying, then it is pretty easy job. Otherwise, it is difficult job. Why it is difficult job? It should be understandable. Now, first concept is divide the problem into n different parts and then try to bring one independent variable that will make all the parts behave exactly same. All the part cannot behave exactly same because odd number have different way and even number have different way. In that manner, segregate odd number and even number. This is odd number, this is even number. Now odd number is 1, then 1 plus 2 plus 3, then 1 plus 2 plus 3 plus 4 plus 5, then 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Where slots are, means slot means x. Slots are means slot means x. Okay, where the slots are, slot means x. Okay, where the slots are x. Oh, oh, oh. Okay, consider this is x-axis. Consider this is x-axis. If this is x-axis, then slot are x equal to 1, this is 0. x equal to 1, 2, 3, 4, 5, 6, 7, 8. Where slots are odd, x equal to 1, 3, 5, 7, like so. And then we have in slot number 1, slot number 3, slot number 5, we have odd number. And each odd number, all odd number if I place in one go, and all even number if I place in one go, then all odd number will come as 1, 3, I'm sorry, 1, the slot number is 1357. The actual number is 1, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4 plus 5, and so on. Means if I try to denote every slot number in same way, everyone should look exactly same. What do you mean? It should not be 1 and then 1 plus 2 plus 3, that is 6. 1 plus 2 plus 3 plus 4 plus 5, that is 15, and so on. All should look exactly same. If that is the way, then we can say each number is x into x plus 1 by 2. Each number is x into x plus 1 by 2. If x is 1, then it is 1. When x is 3, then it is 6. When x is 5, then it is 15. When x is 7, then it would be 28, and so on. Okay, let's talk about the even number we have placed separately, minus 2, minus 4, minus 8. But their slot numbers are 2. When slot number is 2, the number is minus 2. When slot number is 4, the number is minus 4. When slot number is 6, the number is 6, and so on, of minus 6, and so on. Means it is exactly as number of slot number only. If slot number is 2, then it is minus 2. We can say it is minus x. We can say it is minus x. So if I say all the even number are minus x, minus x, minus x, minus x, minus x, where x is the slot number that we change from 2, 4, 6, 8, and so on. This side, all the odd number are x into x plus 1 by 2, where x is 1, 3, 5, 7, and so on. Both are different. So we have to find the addition. We have to find the addition for n number of term here, and I mean n number of slots. Slot is 1, 3, 5 up to number n slot. Here slot is 2, 4, 6 up to n slot. We have done it already in the past video. We have done it already in the past video, where we have unique slot number. I remember in the past video, we took the successive approximation. Successive approximation means if this is x equal to 1, x equal to 3, x equal to 5, x equal to 7, I have function over x. At x equal to 1, function over x is function over x is 1. At x equal to 3, function over x is 6. At x equal to 5, function over x is 15. At x equal to 7, the function over x is 28. If I connect top point of all the points, it will draw a line, and that line is called function over x. We consider that is a function over x. Function over x is x into x plus 1 by 2. Summation of all the vertical, this is what we want. Summation of all the vertical will come as summation x equal to 1. X equal to 1 to n, where n is the slot number, fx. Where x would go 2 by 2. X is 1, x is 3, x is 5. It will jump to 2. Okay, someone would ask me, can we make it jump 1, 1? Can we make it jump half, half? Can we make it jump 1 by 4? Yeah, we can do so. But formula will change. The x into x plus 1, x into 1 plus x by 2, this is what formula we have taken. That will change. Someone would say, let's consider when x is 1, then it is 1. When x is 2, then it is 1 plus 2 plus 3. When x is 3, then it is 1 plus 2 plus 3 plus 4 plus 5, something like that. Then formula will change. It won't be x into 1 plus x by 2. It will be little complex. Someone can try. There is nothing in it. More someone try, more he would validate, or more he would be practicing this new concept. That is successive approximation through which we can calculate all the summation series. This is not the end of the story. End of the story is that we shall be able to do every possible thing through the integral calculus and differential calculus. We do not need a different methodology for doing different things. Okay, we have tried it. So what we did is, if I take x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. When x equal to 1, x equal to 3, x equal to 5, x equal to 7, x equal to 9 is like that, then in that manner, let this is fx, x into x plus 1 by 2. Consider that is a discrete function because it is sampled only at x equal to 1, 3, 5, 7. Now let's consider there is a continuous function called gx, and gx is a set of different sub-area. One sub-area, if in fx, when first vertical is x equal to 1, then let's consider, now there is a gap of 2. Let's consider x to x plus 1 and x to x minus 1, means 1 to 1 plus 1 and 1 to 1 minus 1. There is a two gap area strip that will go up and it will hit another gx like this. Then from now next vertical is x equal to 3. 3 minus 1 and 3 plus 1, width is 2, and it will go hit the gx like this. Means we have as many sub areas in gx as many we have verticals in fx. Both are same. Last fx is at x equal to n. Then sub area will be n minus 1 to n plus 1. This is what we have seen. And then we have to say that summation x equal to 1 to n fx, whatsoever n is, fx should be same as gx. gx gx means gx 1 minus 1 to 1 plus 1 gx dx plus 3 minus 1 to 3 plus 1 gx dx. Both sides of vertical will take a sub-area. Last will be integration n minus 1 to n plus 1 dx dx. Or for any x, fx equal to integration x minus 1 to x plus 1 gx dx. We have seen the result, and result comes as x square by 2 minus, I'm sorry, x square by 2 plus x by, I'm sorry, x square, I forgot, x square by 4 plus x by 4 minus 1 by 12. We'll try again, if we validate before we proceed. So x square by 4, the result should come as fx, x into x plus 1 by 2, or x square by 2 plus x by 2. Okay, x square by 4 integration will be x to the power 3 by 12. Limit is x minus 1 to x plus 1. Okay, that will come as 6. This is what we have seen. 6x square plus 2. 6x square plus 2. X plus 1 to the power 3 minus x minus 1 to the power 3. 1, 1, 2. 6x square plus 2 by 12. X square by 2 plus 2 by 12. Next is x by 4. That will become x, I'm sorry, x square by 8. X square will become 4x. That will become x by 2. X square by 2, x by 2. Very nice. This is what is required one. But we have extra 2 by 12. Minus 1 by 12 integration is x. That will come as 2. 2 by 12. Minus minus gone. So perfect. Okay, the net solution what we are seeing here, net solution what we are seeing here is that integration of gx would go from 1 to n. Now we have taken the area in I'm sorry, the fx is from x equal to 1 to n, where gx will go 1 minus and n1 plus, means integration x equal to 1 minus 1 to x equal to n plus 1. Luckily it is 0. So it will come as n plus 1 to the power 3, n plus 1 to the power 3 by 12. Okay, x square by 4 means integration will be x to the power 3 by 12. N plus 1 to the power 3 by 12 plus n plus 1 whole square by 8 minus n plus 1 by 12. This is what result we are getting, where we have n as odd number. N as odd number. Okay, up till here we are doing same way, the way we achieved in the last example. Now we will proceed for the even number. Now even number is -2, -4, -8, -10 and something like that. Now consider this is x equal to -2, x equal to -4, x equal to -6, x equal to -8. What do you mean? Wait, I'm sorry. If I'm sorry. So x equal to 2, then fx, this is function over x. This is x-axis. This is function over x-axis. In that manner, when x equal to 2, then height is -2. Fx is -2. When x equal to 4, -6. X equal to 8, -8. Now, what will happen if x equal to n, where n is even number? N is even number. If that is the case, then what will be total summation? What do you mean? I mean, summation x equal to 2. Let's forget negative. We will tackle that. Summation x equal to 2 to n fx. What is fx? When it is x equal to 2, then it is 2. I have just omitted the negative. X equal to 4, then it is 4. X equal to 6, then it is 6. X equal to means function is x, just x. Means function over x, summation x equal to 2 to n, function over x will be exactly same limit x equal to 2 to 4 gx. I'm sorry, we have taken the middle one. So if I take x equal to x, then we have fx as 2. Then we will take area 2 minus 1 and 2 plus 1, because width should be 2, because there is a sampling of 2. So width is 2 minus 1 and 2 plus 1. This area strip will go up and it will hit gx. It will go up and it will hit gx. What I say is summation x equal to 2 to n fx equal to limit, integration limit x equal to 2 minus 1 to 2 plus 1 gx dx, plus integration limit 4 minus 1 to 4 plus 1 gx dx, plus integration limit 6 minus 1 to 6 plus 1 gx dx, plus this manner. Okay, if it proceeds in that manner, then what will be the net, what will be the first, what will be the gx? How to find gx? Okay, I have fx as x, gx, dx is fx, gx is 1. We'll start with the 1. Okay, I believe we have done it. We have done it. Okay, and the answer was x. I remember x square by 2. X square by 2. We'll try. Gx as x square by 2. If you come at x, it was x by 2. Just x by 2. We'll try. Then integration will be x square by 4. Limit is x minus 1 to x plus 1. Same. X square will become x plus 1 whole square minus x minus 1 whole square. Then it will become 4x. 4x. 4x by 4 means x. This is what we want, x only. So gx safely I can take as x by 2. Okay, now when I am computing the full term, then it will become limit x equal to 2. It starts from 2 and it goes till n. So 2 minus 1 and last one will be n plus 1, because last subscript will go as n minus 1 to n plus 1. So it will go as, now the, if I want to add all the vertical of fx to gx, then I will compute all summation of all the sub area. So the first sub area was, if you remember, it is 2 minus 1 to 2 plus 1. So the lower limit 2 minus 1 would be retained. Last sub area was n minus 1 to n plus 1. The highest will be retained. Okay, in that manner, what it would be? Now it would be hitting everyone's mind. In that manner, what it would be? Okay, if I calculate in that manner what it would be, then it would come as sigma x equal to 2 to n fx, where fx is x, equal to limit x equal to 2 minus 1 to n plus 1 gx dx, where gx is x by 2. If I integrate it, it will become x square by 4, 1 to n plus 1. That will become n plus 1 whole square minus 1, 1 square, 1. n square, that will become the x square plus 2x plus 1, that is n plus 1 whole square minus 1, 1, 1 gone. X square plus 2x. Oh, sorry, n, we have put n. Okay, then it will be n square plus 2n by 4. This is the solution. N square plus 2n by 4. Someone can corroborate this. Someone can validate this. Let's try n equal to 12. N equal to 12. N square will become 144. 144 plus 2 into n, that is 24. 144 and 24 will become 168. Once up 168 by 4, that would become 3 and 2 4 8, 38. That will become 38. Okay, that is n equal to 12. Let's try adding it. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. 8 plus 10, 20. 20 plus up. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. 20 plus 10 is 30. 30 plus 12 is 42, not 38. So we are wrong. We'll try again. What we are ghosting, what we are jumping, is solution is x square plus 2x by 4, or n square of limit was we took 1 to n plus 1. Answer is x square by 4, n plus 1 whole square minus 1. N square plus 2n by 4. Perfect. N we have to take 12. So 12 into 12 will be 144. I think so. 144. Not 2. Okay. 12 into 12. 12 into 10. 12 into 10 is 120. 12 into 11 will be 132. Plus 12, 144. 144 plus 2n. That is 12 into 2, 24. 144 plus 24 is 168 only. So I have not made any wrong. 168 by 4, that is 4 plus 42. 42 1. Okay. So equation is perfect. If I am adding up to n number slot of all the even number, n slots of all the even number, then it would become n square plus 2n by 4. But make sure n is even. If I add all the slot of the n odd number, then it will become n plus 1 to the power 3 by 12 plus n plus 1 whole square by 8 minus minus n by minus n plus 1 by 12. This is what we have said. Now if we have to add both the summation, because the question in exam, consider question in examination is 1 minus 2, then 1 plus 2 plus 3, minus 4, then 1 plus 2 plus 3 plus 4 plus 5, then minus 6, then 1 to 7, minus 8, 1 to 9 addition. Like that up to slot number 33. So slot number 33, that is the question. Means even number will go up to 32 and odd number will go up to 33. Okay, now up to 33, if I want addition of all the odd numbers, then it will become 33 plus 1 to the power 3 by 12 plus 33 plus 1 whole square by 8 minus 33 plus 1 by 12. This is the answer is. Okay, and then if I talk about all the even number, then it will go minus, and then because it is negative, minus, then n square plus 2n, where n is 32. So both are different. Someone would say you settle down with same n. Don't take separate n. Yeah, you are taking separate n. For odd numbers, you are taking n as odd. For even number, you are taking n as even. Now I am saying you add up to 33 slot where n is 33. Now solve it. Now n is 33. I can place in the odd number summation n plus 1 to the power 3 by 12 plus n plus 1 whole square by 8 minus n plus 1 by 12. But this n we cannot put here because that is even number. What n I can put? Now if odd number n is higher than the even number n, then in the n we will place n plus 1. Hope n minus 1. N minus 1. Okay, means if this is n is 33 and even number n is 32, then from this, if I take this n as a reference, because n is 33, so if I take this odd number n as a reference, then this n is one less than that. So we have to resettle the formula. Now we have n square plus 2n by 4. N will become n minus 1. N will become n minus 1, and then we can settle down and we will merge it. So 2n square will become n minus 1 whole square plus 2n minus 1. It will become n square plus 2n, I'm sorry, n square minus 2n plus 1. And this side 2n minus 2. 2 gone, 2 and 2 and gone. N square minus 1 by 4 is the solution. Now we can happily go and merge both where n is odd number. N plus 1 to the power 3 by 12 plus n plus 1 whole square by 8 minus n plus 1 by 12 minus and then n square minus 1 by 4. Okay, if someone calculated this is what the summation will be up to 33. Someone would say 33 is not the last, 32 is the last. Okay, summation of all this series up to minus 32. That is the question. Then even number is higher than odd number. Odd number slot is going up to 31 only. So even number is going up to 33. So whatever n we have taken in even number, that is perfect. So that will come as n square plus 2n by 4. Now I have to settle down this n. So this n will be 1 less than this. So n plus 1 whole square to the power 3 will become n minus 1 plus 1, where n is even number. That will become n to the power 3 by 12 plus n square plus n square by 8 minus n by 12 minus n square plus 2n by 4, where all n is even number, that is 32. This is the way. I'm not saying that okay, you remember all this thing, but remember the step and remember the minuteness of the problem. Then someone can really crack it down. Amazing, mind blowing. This is what is not available in any. I will try to calculate the left hand side. We have taken the right hand side area. To calculate the summation, we have taken central area, x minus 1 to x plus 1. We have taken x to x plus 2. We will try x minus 2 to x. That is also possible, left side area, and then we will see how to come to it. This is something that is not available in any of the book. Solving all the series summation through a single way of integral calculus. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone. 9483160610 telephone number. +91 is the India country code.